Alright, so here we have problem 52 of chapter 28, and that question asks, a very long uniformly charged cylinder has radius capital R and linear charge density lambda. Find the cylinder's electric field, A, outside the cylinder, little r is greater than or equal to big R, and B, inside the cylinder, little r is less than or equal to big R. And then part C asks to show the answers to parts A and B matching. So basically saying that they match it, little r equals big R. Alright, so in part A, we have Gauss's law, and we have E dot dA on the left, and that will turn into just E times A, because on the left and right sides, on the flat sides, you'll get a cosine of 1, and or a cosine of 90, sorry, and that will give you 0. And so the left and right sides of the cylinder will go to 0, and you'll be left with just EA for the wall side of the cylinder. And that is equal to the enclosed charge over epsilon naught. And so you can basically just plug that in. You get E equals to, I moved the A into the denominator of the other side. So the Q equals lambda L, and on the bottom you'll get 2 pi R times L, and then the epsilon naught is still there. And then your L's will cancel, and your final result for part A is E equals lambda over 2 pi little r times epsilon naught. And that is electric field for the R outside of the cylinder. And in part B, that asks for the R inside the cylinder. So you have to use volume in this one, because in the question the cylinder is uniformly charged, so you can't just be using the surface area of it. So you start off the same. You'll just be left with EA equals enclosed charge over epsilon naught. That'll start off the same. And then move the A over to the other side again. But instead of the lambda, you'll have rho times, and it'll be the volume of the cylinder. That's pi r squared times L. And over the area, which is 2 pi RL and epsilon naught. And simplification to get the rho out of the equation, you can lambda D equals rho times the pi r squared D, and you just end up with rho equals lambda over pi r squared after some simplification on the other side. And you plug that in for rho into your part B, and after some simplification, your final result will be E equals 1 over 2 pi epsilon naught times lambda r over r squared. And that is the electric field for the R being inside the cylinder. And then the last part of the question is part C, where R equals big R. And pretty simple. Just plug in, just replace the little r in the equation we just found in part B with a big R, because they're equal now. And so those will cancel, and you'll end up with 1 over 2 pi epsilon naught times lambda over r, because the r over r squared will just be 1 over r squared. And that's it.